Hello everyone, this is Pankaj and I welcome you all to a new day, new question series. So once again we have one more question on the screen. So let's see what we have in today's question. So basically the question is saying temperature difference of 120 degrees Celsius is maintained between two ends of a uniform rod AB. So this is our uniform rod AB whose complete length they have given twice L, and in the question also they have mentioned like this one is L, this one is L by 2, so of course this one will also be the L by 2. Now another bent rod whose name is basically PQ, this one is that bent rod of same cross section area as that of the AB and its length is L by 2. So complete length is L by 2. Out of this one is L by 4, this one is also L by 4, so L by 4 will be L by 2, and this part will be L, so L plus L by 4 plus L by 4 will be equal to 3L by 2 is connected across the AB as we can see in the figure. In steady state means like same current will flow through this part. Then they are saying temperature difference P and Q will be close to, they are asking. So temperature difference between A and B they have given, and they are asking us to find the temperature difference between P and Q. So we know that basically in this case, or not in this case, formula we have for the thermal resistance, that formula says R is equals to L by Ka. So we will assume that material is same, and of course they have mentioned that area is also same. So because they have not mentioned any kind of thing about the material, so I will say that my material is constant, it is not changing. So because of that K will also remains the constant, and A of course they have said that it is constant. So resistance will be directly proportional to length. So this is the relation I am going to use for finding the resistance, because I am going to convert this given diagram into equivalent electric circuit diagram. Resistance of this part, 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 and resistance of this part. So R is directly proportional to length we have. So for this part it will be R by 2, for this part it is R, for this part it is again R by 2, this part will be R by 4, again R by 4, and again R. So these are the values of resistance. Let's draw them in the equivalent electrical circuit diagram. So this one will be our equivalent electric circuit diagram. So as I have said, this part is R by 2, this one R, this one R by 2, again this part is R by 4, this part is R by 4, and this part is basically R. Now we know that here, as we can see, they have set steady state. Steady state means like same current will flow. So we know that if steady state is there, so current, that is we can say thermal current, okay, which is I am representing by H, in AB part will be same as that of the PQ part. So heat current in the AB part will be equals to heat current in the PQ part, because they have mentioned that it is the steady state. Steady state means same current will pass. So we know that the formula which we have for the H, because Ohm's law is V equals to I into R. In thermal part, this V will be replaced by delta T, I will be replaced by H, and this R will be your thermal resistance. So from here your heat current H will be equals to delta T by R. This is the relation I am going to use. Okay, so for AB part I will need the value of resistance, that is the total equivalent resistance, as well as the resistance in the PQ part I am going to need. So first what I will do, I will simplify the entire circuit so that I can have the R equivalent for the AB part. Okay, now we can see that this one is R by 4, this one is also R by 4. So this R by 4, R and this R by 4 are in the series. So series combination of R by 4 and R by 4 will be R by 2, and R by 2 and R will be 3R by 2. So for this part equivalent resistance is 3R by 2, and for this part it is R. So this 3R by 2 and R in the parallel combination. So let's first find that. I am naming it as a equation number 1. Okay, so we can see that 3R by 2 is in parallel combination with R. Okay, so let's try to find. We know that it is R1 into R2 by R1 plus R2, that is 3R by 2 plus R, which will be 5R by 2. Now this 2 and 2 will get cancelled out, R and R will get cancelled out, so final value will be 3R by 5. So first thing what we have done, we have found the equivalent of this entire 3R by 2 and R. Now the equivalent of this part, how much we got? 3R by 5. Now 3R by 5 is in series with the R by 2 and R by 2, that is R. So series combination, next we have series combination of 3R by 5 and R, which will be equals to 8R by 5. So total resistance is basically 8R by 5 of the AB part. Okay, so what we got? We got resistance for entire AB part is 8R by 5, and similarly we can have resistance for PQ part. Okay, resistance for PQ part. PQ part means this part. For this, if I try to find the resistance, we have already found that this value R by 2 and R is basically 3R by 2 along with the parallel. So for this entire part, how much value we got? 3R by 5. So we are going to use that direct value, which is 3R by 5. Now from equation 1, so from equation 1, what we have? Heat current in AB part, that is delta T by R. So between A and B they have given the temperature difference of 120. So 120 upon value of R AB, how much we have? It is 8R by 5. Similarly, temperature difference between PQ part we don't know, so I am calling it as basically X into resistance for PQ part, how much we have? 3R by 5. Now R cancel, 5 and 5 cancel, then we will be having basically X equals to 120 into 3 by 8. Okay, so 4 2s are we have, then 4 3s are 30, and again 2 1s are, and 2 15s are. So 15 3s are 45. So final value of X, that is temperature difference for PQ part, how much we are getting? 45 degree Celsius. So this is the answer which we need. Let's check the option. So option number 2 will be our correct option. Okay, thank you.